Welcome to using summation notation, sigma. So right now, we know that if we have a series 2 plus 6 plus 18 and so on, right? I'm multiplying by 3 each time. We know that we can find the sum of this using the formula S sub n equals a sub 1 plus, not plus, minus a sub 1 times r to the n over 1 minus r. In this video, we're going to talk about representing the sum in a different way, using sigma notation. Now, you might know the Greek letter sigma looks like this. It's kind of like an E with a little bit different, but it does kind of look similar to an E. It's called sigma, the Greek letter. So just remember that a sequence is a list of terms, but when we add those terms together, we get what is known as a series. Now, in order to specify the addition of a sequence, or summarize it instead of writing it all out, we can use summation or sigma notation. When we're talking about the geometric series formula, that is on your reference sheet, what we talked about in the other videos, but when we're talking about summation or sigma notation, we're talking about what this video is discussing. Now, remember that a sequence is a sub 1, a sub 2, a sub 3, all the way up through a sub n. We can write the sum of the first n terms of the sequence using this expression. Now we're going to break it down. We're going to talk about the sigma, all right? Sigma specifically means the sum, right? And we use Greek letters a lot in math. Like if you ever see the change in y over the change in x, we know that delta, right, that's the Greek letter, represents change. However, every time you see the letter sigma, that's going to represent the sum. So we have the sum of what, right? The sum of a sub k. This is actually a formula for a geometric series or sequence. So a sub k is your explicit formula. Of the sequence. So you're telling them to take the sum of this sequence, so you have to tell it what terms you want it to use. Do you want the sum of the first 5 terms? The sum of the first 10 terms? So the bottom is where you're starting from, and the top is where you're going to. So k equals 1 is your lower bound. It's called your starting term. K equals n, the n up top is your upper bound. It is your ending term. So sigma represents that you're finding the sum of the formula from the bottom starting term, k equals 1, through the top of n. Let's actually try this out with numbers because I think it'll be a lot easier. So they want you to evaluate this. Now the way you're going to say it is the sum of 3 times 2 to the k minus 1 power from k equals 1 to 7. In other words, we're finding the sum from the first term to the 7th term. There is a way to do this in the calculator, but first we're going to talk about actually doing it by hand. That way we can figure out what's really going on. So we have the sum of, let's see, we're starting with k equals 1. So I'm going to start by plugging in 1. So I have 3 times 2 to the 1 minus 1. And if you plug that in, you're going to get 3. Now you're going to add, because remember sigma means sum, this is a series, and you're going to plug in 2. So we have 3 times 2 to the 2 minus 1. And that's going to give me 6. You're going to keep on going and do 3 times 2 to the 3 minus 1. So we get plus 12. And you're going to keep on doing this 7 times until you get to 7. So that's going to be 3 times 2 to the 7 minus 1. Which would be 192. I swear if you were to do this 7 times, you would get 381. I don't want to do this 7 times because it is very tedious. And the good news is that on the regions, you can just use the formula, you can use the calculator to actually evaluate it. You don't have to expand it like this and do it all by hand because this is annoying. So let's talk about how to use your calculator to get this done. Ignore this part. We're going to use the second option. So in order to get sigma, we're going to do alpha window, which is where we usually go for things, right? It has absolute value, it has log base, it has whatever root you want to take. And if you notice, choice 2 has the summation formula. So we're going to hit alpha window, choice 2, summation. Now, you do have to tell the calculator what you're doing. Obviously, you can't plug k into the calculator because variables in your calculator are always x. So you're going to hit x equals, and if you're looking at the problem, we're starting from 1, going up to the 7th term, and then you have 3 times 2 to the x minus 1. So notice how I made the number, the variable underneath sigma and x. So I made my actual equation x over here too. In the actual question, we had a k and a k in the formula as well. You want to make sure your variables are the same and that you don't use an x with a k or an x with an n or whatever like that. Keep your variables matching. Anyway, just hit enter, you're all done, and the calculator will tell you that the answer is 381. So 2 different ways to do it. Let's try another. This time we're evaluating the sum of k squared from k equals -1 up until 3. If you notice, the last problem was geometric, right? Because this formula is for a geometric sequence, right? You have a sub 1 times r to the n minus 1, or in this case, k minus 1. This problem is not geometric because all you're doing is squaring the number. It's okay that it's not geometric. You can use sigma with arithmetic series or geometric series, right? So this one's a little bit different than the geometric series formula that we specifically talked about the other day. So we're going to put this one in our calculator now. We're going to go to alpha window, choose choice 2. We're starting at x in this case of -1, going up until 3. And the explicit formula, the pattern going on, is x squared. And it tells you that your answer is 15 if you were to actually do this. Right? So try not to do it by hand. Do it the easier way. Just use the calculator. Now, if you want to actually write it out using sigma notation, you need several things. You need your starting term and your ending term, right? Right now, in this case, I'm starting at a sub 1 and I'm ending at a sub 9, right? But in order to actually do this, I need to find my explicit formula. So step 1 for this is to figure out what's the formula to represent this series. If you notice in this pattern, we are subtracting 2 each time. So that means I'm going to go with the explicit arithmetic formula. That's a sub n equals a sub 1 plus n minus 1 times d. My first term is 12, and my common difference is negative 2. I'm going to use this formula to figure out my summation notation. So step 2, write it with sigma. Make sure you actually use parentheses around this. That way it looks like the entire thing is attached to the sigma as opposed to just the 12 being attached. And from there, you need your upper and lower bound. So we're starting at n equals 1, and we're going up to the 9th term. And that would be your answer. You only put the variable on the bottom, not up top. You don't have to use n. Usually the Regents does use n. Sometimes you can use other variables like k or x if you want to. Again, just make sure that if you decide to put an x here, that you have an x here as well. And let's try one more example. In order to do this, we're going to find our explicit formula first. In this case, you are multiplying by 2. So because we're multiplying, I'm going to be using my explicit formula for geometric sequences. So that's a sub n is equal to a sub 1 times r to the n minus 1. My first term is 3. My common ratio is 2. And this is what I'm going to be using in my summation notation. So I have the sum of 3 times 2 to the n minus 1. We're starting from n is equal to 1, right? Your first term. And we're going up to the 5th term. And you're done. Now, just keep in mind, you do not need to start from n equals 1. You can start from n equals 3 and go up to 5. That means you are adding the 3rd, 4th, and 5th term together. If you were to start at n equals 2 and go up to 9, that means you're adding the 2nd through 9th term together. So you don't have to start at 1. It's basically, you just have to read it and see what term are you starting at, what term are you ending at. And you're only going to do this when you specifically see use sigma notation or summation notation. If they're asking you for a formula, use the one on your reference sheet that we talked about in the previous video. However, that formula can only be used for geometric series, whereas summation notation can be used for geometric, it can be used for arithmetic, it can be used for additional ones, right? That's not arithmetic nor geometric. We had one formula before when you were just squaring terms, right? That's not either of them. So you can always use summation notation to represent a formula that's going on. Just make sure you use the explicit formula and not the recursive, because that has 2 pieces of information and you can't plug that into your calculator. And that's all for this.